Hi there, my name is Matt, and just because I can, I'm going to illustrate some quantum mechanical principles using some truffles that I got for Christmas. This box of Godiva European dessert truffles was given to me by a coworker. It came with a total of 6 truffles, 12 truffles in 6 different varieties. And I've eaten a lot of them, so there are 2 left. And you can see they both have a milk chocolate coating. And based on the ingredient list in the based on the ingredient list in the back of the box, the ones with the milk chocolate coating are either caramelized apple tart truffles. Indulge in the delicious delight of caramelized apples wrapped in a deeply luxurious shell of milk chocolate. Or bananas foster truffles, which the description is ignite your senses with the smooth decadence of bananas sprinkled with delicate brown sugar and enrobed in Godiva milk chocolate. Wrapped versus enrobed, I guess. So because I've eaten, I had help, but 10 of these truffles have been eaten, and one of them was apple, one of them was banana, which means that these last 2 truffles are apple and banana. Now, here's where the quantum mechanics comes in. Each of these truffles actually has a 50% chance of being apple and a 50% chance of being bananas. So if you took this one truffle and asked a normal person what kind of truffle is it, they would say, I don't know, it's either apple or banana. I won't be able to tell until I eat it or cut it open. Leave me alone. But if you asked a quantum mechanic what kind of truffle this is, they would say, well, it exists in a state of sort of quantum uncertainty, a quantum state in which it's simultaneously apple and banana, and it will not resolve into one or the other until it is observed, either by cutting it open or eating it or some other way of figuring out exactly what it is. It's similar to the Schrodinger's cat principle, where you have a cat in a box that has a 50% chance of being alive and dead, so the cat is both alive and dead. Slightly less morbid example. So this truffle is simultaneously apple and banana until it is eaten, according to quantum physics. Now, another principle is illustrated by the other truffle. This is the other one. Because I know that there's 1 banana and 1 apple left in the box, if this is banana, that means this is apple. And if this is apple, that means this is banana. So both truffles exist in a quantum state of being both apple and banana, but we know that they're opposite, so that as soon as we measure one, we'll know what the other one is. Now, that's called entanglement. That means when we measure this one, we will instantaneously know what this one is. And the weird thing about entanglement is that I'll illustrate it by putting this truffle over here. Now, I just put that truffle over there to illustrate a distance, which is a very trivial distance, but it'll hopefully prove the point. The weird thing about entanglement is that, as I said, as soon as we measure this truffle and figure out whether it's apple or banana, we will instantaneously know what kind of truffle that one is. We'll instantaneously know that it's the opposite. That means that by measuring this truffle, the quantum state of that truffle is altered immediately. The reason that's strange is because under relativity, nothing is supposed to happen faster than light. So under relativity, if we measure this truffle, it would send some sort of signal over to that truffle, and only once the signal was received by that truffle will the quantum state of that truffle be altered. Whereas under quantum mechanics, because we know that these truffles are opposites, as soon as we measure this one, no time displacement at all will take place before the probability of that other truffle resolves into either apple or banana. This is what Einstein called spooky action at a distance, which sounds a lot cooler in German. So, without further ado, I will now illustrate the quantum mechanical principles of Schrodinger's cat and entanglement by biting into this truffle and seeing if it's apple or banana. Now, as I said, not only will we be altering the quantum state of this truffle by resolving it into either apple or banana, but will instantaneously, faster than the speed of light, alter the quantum state of that truffle by also resolving it into the opposite of this truffle. So Here we go. Get ready for some hot fashion light action right here on my webcam, in my office, in my home, on the internet for all to see. Faster than light. Here we go. Banana. So, as soon as I bit into that, as soon as I said banana, that became apple. So let's go check. Okay. Yep. Apple. So, but I knew that because I bit into this one and it was banana. So there you go. Sometimes science is tasty, but I have to admit the apple and banana truffles, there's a reason these are the last two in the box. So, happy holidays, learn science, and have a great new year.